Welcome to Homework Lib.
Chapter 14, question 86. The enzyme urea catalyzes the reaction of urea with water to produce carbon dioxide and ammonia. So at first, they want us to write out a balanced equation for the reaction catalyzed by urease. So the urea NH2 CO NH2 with water H2O would give us carbon dioxide CO2 plus ammonia NH3. Now, first I would start with balancing out the nitrogens. So we have one nitrogen over here, one nitrogen over here, so two nitrogens. And I have a one nitrogen over here, so I need to multiply this by 2. Then I will look at the carbons. There's one carbon on the left-hand side, and that's it. So one carbon. And there's one carbon on the right-hand side, so this looks good. Then let's look at the oxygens. There's 1, 2 over here, 2 over here. So oxygens looks good. And let's look at the hydrogens. 2, 2, 2, there are 6. And 2 times 3, there are 6 hydrogens. Hydrogens look good. So this is going to be our balanced equation over here. At B, if the rate of the catalyzed reaction were the same at 100 Celsius as it is 21 Celsius, what would be the difference in the activation energy between the catalyzed and uncatalyzed reactions? So to make it a little bit more simpler, let's write the catalyzed and uncatalyzed reaction rates. Catalyzed is 3.4 times 10 to the power of 4 at 21 Celsius. But this question says it's going to be the same at 100 too. So I'm just going to write 100 Celsius over here. Uncatalyzed is going to be 4.15 times 10 to the power of negative 5 at 100 Celsius. So they're giving us this 100 Celsius equal. That's the main way to be able to solve this question. Because then what we need to use is the Arrhenius equation. So let's recall what the Arrhenius equation was. K equals to A e to the power of negative EA over RT. Now this R is going to be 8.314 and T is going to be in Kelvin, so it means Celsius plus 273. And EA is going to be in joules. So let's write the K1 for our catalyzed and K2 for our uncatalyzed versions. So K1 is going to be 3.4 times 10 to the power of 4 equals to A times e to the power of minus EA1, because our activation energies are different. That's what the question suggests us. Divided by 8.314 times 100 Celsius plus 273 is 373. And the other one, 4.15 times 10 to the power of negative 5 equals to A e to the power of minus EA2 divided by 314 times 373. If I divide these two sides to each other, what we're going to get is 3.4 times 10 to the power of 4 divided by 4.15 times 10 to the power of -5 equals to, a's cancel each other, e to the power. When we do the powers, if you're dividing, we're going to subtract one from the other one. So it's going to be EA2 minus EA1 divided by 8.314 times 373. So now how we are going to get this EA2 minus EA1 is if we take the natural log of both sides, then we are going to get this is going to cancel each other. So we're going to just be left with this side of the equation, and we're going to get a number from here. Then multiply this number, both sides, by 8.314 times 373. We're going to get EA2 minus EA1 to be 784.51 joules. That's the difference between the activation energies. In actuality, what would you expect for the rate of the catalyzed at 100 Celsius as compared to 21? I would expect the rate to increase, because if we increase the temperature, then we increase the K. As the temperature increases, the possibility of two molecules finding each other is increasing. On the basis of part C and D, what would you conclude about the difference in activation energies for the catalyzed and uncatalyzed reactions? So let's draw a potential energy surface for this. Let's say this is the uncatalyzed version. And if I use a catalyst, what it means is I'm going to put extra steps into the overall reaction. So these extra steps are going to be something like this. So as you can see, normally this would be my energy of activation, but with the catalyst, I could drop down the energy of activation over here. So if I can go back to the question, with the addition of the energy of the activation, as you can see, at 2, which is the uncatalyzed, and 1, which is the catalyzed, the difference is 784 joules.